This sequence of the video shows using sodium silicate to deflocculate casting slip. So I'm loading sodium silicate into a small syringe and I'm adding that to pre-measured water. In this case we have 40% water and 0.3% sodium silicate. And I have this on a very sensitive gram scale. And the water was weighed out, and then the scale was zeroed, and then the sodium silicate was added. And this particular clay slip, most clay slips have a variety of clays in them to create the casting properties that are needed. This has EPK, which is a Florida kaolin, and it also has Graulig, which is a blended English kaolin, and it also has ball clay, which is very important for casting qualities. So these materials are being individually added to the water, and then the scale is zeroed or tared before the next addition. And so adding this and tearing the zero and the ingredients, you have to be careful because once you get the material in there, it's hard to get it out. So this is the reason I'm being so careful with the spoon to watch the scale and put a little bit in at a time. I mean, all these things could be weighed in separate containers, but doing it this way, if you're careful, is quicker and easier. Scale is sensitive enough, just walking around on the floor will sometimes create an error. So I'm just watching the scale and then adjusting it. And I'm marking my my recipe sheet, which has been printed from the Glaze Master program, which can be used for glazes or bodies either way interchangeably. So I'm going through my wheeled carts. I keep all my dry materials on wheeled carts so they can be added. And the first ingredient was an EPK. It was Graulig, and this is the EPK edition here. EPK standing for Edgar Plastic Kaolin, which is a mine in northern Florida. Same kind of clay that's used in kaopectate. So when you take a spoonful of kaopectate, you know what clay tastes like. So I'm adding these plastic materials, these clays, to the water initially because the clays are slower to wet up. The rest of the body is made up of feldspar and silica, which don't have any plastic qualities and are easier to wet. So I'm just taking a small teaspoon here and just getting the wetting process started. A little bit of the clay material will end up on the spoon, but I'm not too concerned about that. So this is a hand drill driven plunger, do-it-yourself device made from a broken barrel lid. And you can see it's churning the material up and there's lumps and bumps in it. And some of the slip is sticking to the sides of the small bucket. It's about a half-gallon bucket. So this is making a batch which is 2,000 grams dry. So it would be about 2,400 grams, 2,500 grams. No, I'm sorry, 2,800 grams total weight with the water. And it works best if you don't suck air into it. If you do, it's not that big a deal. Most people recommend screening your slip. Well, in this case, if it's properly mixed, you don't really need to screen it. So I usually thoroughly plunge it this way, and typically it's recommended that you mix your slip and leave it overnight, but this small batch, it's easy enough to mix a small test batch, and as long as it's thoroughly plunged, to go ahead and use it. So ordinarily we would take a specific gravity on it, and that would tell us exactly how much dry material we had relative to the wet. And here we have a couple of small two-piece molds. This was made a little unconventionally. The top part of this mold was simply turned on a lathe from a solid block of plaster, and I've got a couple of rubber bands, and I'm using the rubber bands to hold the top mold section in place so it doesn't shift. And I don't really have any, there's no way to register the top mold and the bottom mold in this case. I just do it by eye. So this is taking a mold for a small glass and simply turning a top for it to turn the glass tumbler mold into a bottle. So it's just a rough casting project. None of this is complicated. It just shows the basic processes. And here's our slip, which is deflocculated, and we have checked the specific gravity to determine that it's appropriate for casting. This is approximately 40% water and 0.3% sodium silicate, and you can see it's very fluid. If it weren't for the deflocculant, it would be, it wouldn't pour at all. So I'm sort of watching it as it comes up because I don't want it to suddenly come into the neck of the bottle and overflow. So I want it to sort of top up, and you can see it coming up there. Now, since the bottle has a narrow neck, it's going to quickly absorb water into the mold, and that's going to need topping up. So this shows the assembly of a similar mold. And I'm being a little clumsy getting the rubber bands on. The rubber bands are a little bit small for this application. Just want the rubber bands on so that they put uniform pressure on the top mold piece, and there's sort of topping up the mold. Just in a minute or two, the water absorbed by the mold the slip will actually drop, the height of the slip will drop. So particularly on a bottle, you have to keep watching it and topping it up a little bit. So deflocculated slip like this has a very slightly syrupy quality to it. It flows. If you don't have your deflocculant right, it'll sort of gel. And if you just stir it in your container, and here it is, I've built up the thickness I want, and I'm draining it out. Well, there's a little bit of an airlock initially, and then it starts chug-a-lugging out. And I don't depend entirely on the rubber bands. I sort of physically hold the top piece in place. And again, since it has a narrow neck, it pours out a little slowly. So I sort of rotate it so that the slip can drain out, and then eventually I'll set it upside down on a stick to raise one edge. So again, all of this is just basic slip casting. There's nothing special about any of this. It's something anybody could do. Just pay attention to the particular details. So you already see it's already separating. And I'm using a little fettling knife to cut off the excess. Traditionally on a piece like this, you'd use what's called a spare, or an extra section at the top, but this is a very simple mold. I don't have any spare at all. In the background there you see two other bottles that are bisque that were cast in a similar manner. Okay, this is not dry. I'm sort of wiggling it, and so the piece hasn't separated. It hasn't, the molds haven't absorbed enough water to allow it to separate, and there the top comes off. And you can see the lathe turned shape on the top of the base mold, which, as I said before, is just sort of a tumbler of glass, drinking glass form. So these two molds have actually got two slightly different top shapes. One is a little more angular and one has more curve to it. So this is just an experiment for some crystalline glaze tests, and that shows the piece coming out of the bottom mold. And there's a bit of flash around the edge which will be sponged off, and a little bit of shadow shows that, and here's the sponging of the flash to smooth that joint off. And you can see a little bit of pimples on the upper piece. That's where there was some air holes in the top mold piece because the plaster that was turned wasn't really completely de-aired. And this one has a crack because I tried to pull the top off a little too soon, but that crack can be fairly easily repaired by just putting a little slip on there. The slip will draw into the end of the crack. And I'm just smoothing it out with my finger. Later, when this dries, I'll use a sponge to clean this up. So I'm just overdoing it to be sure there's enough slip to soak into that crack and heal it up. Shrinking makes it more apt to come out because it's smaller than the mold.